Hello everyone, myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about the applications of second order and first degree linear differential equation with constant coefficient in electrical circuits. How we can apply the higher order differential equation in electrical circuits. So I want to discuss in detail the application of higher order differential equation in electrical circuits. The formation of differential equation for an electrical circuit depends upon the following law. If we are forming a differential equation for any electrical circuit, then we should apply the following law. The following law and following terminology is very important for any electrical circuit. So here some definitions and some terminology and some units we are discussing here. So number one, definition of current. I want to discuss about current. What is current? Every person know about the current. So basically this is very important component of the circuit. In any circuit without current, that is not complete. First component of any electrical circuit is current. Without current, there is no possible to live these days. So now I want to discuss about the definition of current. So rate in change in charge in time t. Rate in change in charge in time t is known as a current. So the current is represented by I. I is the notation of current. So I equal to dq over dt. dq over dt means rate in change in charge, or we can say difference in charge and difference in time. So the ratio between difference in charge and difference in time. So the division of difference in charge and difference in time, that is known as a rate in charge. Difference in charge with respect to time is known as a rate in change in charge, that is known as a current, and that is represented by I. So I equal to, this is formula, I is current and I equal to dq over dt. Now next, voltage drop across resistance. If any resistance voltage drop from the resistance, then we can write Ri. If in our circuit we are using resistance, any voltage flow from resistance, then we can write Ri. Voltage drop across any inductance. Inductance means L. L is inductance. L is notation of inductance. So any voltage drop across the inductance, then we write formula L di over dt. L multiply di over dt. Di over dt is rate in change in current. Rate in change in current multiply by L if any voltage flow from the L. So this is basic terminology which we are using in our circuit to make a differential equation. Next, voltage drop across capacitance. Any voltage drop from any capacitance, then we write Q upon C. Q is charge and C is capacitance here. So we write Q upon C. Suppose in our circuit we are using resistance and any voltage drop from this resistance, then we write Ri. Next, any voltage drop from the inductance, then we write L di over dt. At last, if any voltage drop any capacitance in our circuit, then we write Q upon C. So for capacitance, we write Q upon C. For inductance, we write L into di over dt. And for resistance, we write R into I. So basically, these three very important terminology in any circuit, which we are using to make a differential equation in any circuit. Now, we want to define some unit of given terminology. Unit is very important part of any component. Suppose first 5 number, I is denoted as a current and unit of current is ampere. Every person know about current and about unit. But now we are repeating here. What is the unit of current? Here Q is the denote charge and unit of charge is coulomb. R represented as a resistance in our circuit and the unit of the resistance is ohm. Now L represented as a inductance and unit of inductance is Henry. Henry is the unit of inductance. At last, C represented as a capacitance and unit of capacitance is farad. So these units are very important. These units may be asked in any objective questions. So there is very compulsory to be remember the unit of these terminology in circuits. At last, E is electromotive force, EMF. Short form we write EMF. This is constant or we can say the voltage. So unit is volt. Next one is V is variable voltage. The unit is also known as a volt. Next we want to discuss in any electric circuit about the law. We want to discuss about the law which are using in any circuit. That is known as a Kirchhoff's law. Kirchhoff's law is given by a famous scientist, that is the name is Kirchhoff's law. Kirchhoff's is a name of a scientist. So basically Kirchhoff's have given 2 laws for any circuit. Without these 2 laws using, we cannot calculate any value in a circuit. If we want to find any value in a circuit, then we use these laws. So first law is voltage law and second law is current law. So these 2 laws known as a Kirchhoff's law, because these 2 laws have given by the Kirchhoff's. So these laws known as a Kirchhoff's law. Number 1 voltage law and number 2 current law. So voltage law. What is voltage law? The algebraic sum of the voltage drop around any closed circuits. Any algebraic sum of voltage drop around any closed circuits is equal to the resultant electromotive force in the circuit. Okay. Suppose I am making here diagram. So this is inductance. Okay. This is known as a L, inductance. And next, this is capacitance. And this is inductance. This is resistance, like this. And this is E, electromotive force. Like this. So this is L, this is C, this is R. Any voltage flow from this circuit, then voltage flow from L. So L, first is L, then we write number 1, di over L di over dt. L di over dt. Second, flow from C, then we write second Q by C. Third is R, then third point right is Ri. Okay, so these results 3. So this voltage law saying that total voltage, sum of total voltage, this is the voltage from inductance, this is the capacitance, and this is the resistance. So sum of total voltage in any circuit equal to total electromotive force. This is known as a voltage law. And current law, at a junction or node, current coming is equal to the current going. This is current law. At a junction or any node, current coming is equal to the current going. So now I want to discuss about circuits. How many type of circuits? So there are basically 3 type of circuit. Number 1, LR circuit. LR circuit means a circuit which containing inductance and resistance. Number 2, CR circuit. CR circuit. This is second circuit in a circuit which containing capacitance and resistance. So basically these 2 circuits we have discussed in last lecture, because in these 2 circuits we apply first order and first degree differential equation. Not higher order differential equation we can apply here. So we have already discussed the application of first order and first degree differential equation, and in that lecture we have discussed about CR, LR and CR circuits. But now today in this lecture I am going to discuss about the application of higher order differential equation in electrical circuit. So there is only one circuit which containing LCR circuit. That is known as a LCR circuit. A circuit which contains inductance L and capacitance C and resistance R. All 3 components contained in a circuit that known as a LCR series circuit. All components contained in a series form. Then that circuit is known as a LCR circuit. And in LCR circuit, we apply the higher order differential equation. The application of higher order differential equation can be used in LCR circuit. There are 3 components: lattice rectum, capacitance and resistance. If in a circuit there is only 2 components, suppose lattice rectum and resistance or capacitant and resistance, it means we can apply in that circle only first order and first degree differential equation. But now we are discussing here LCR circuit. In LCR circuit, there are containing 3 components: inductance, capacitance and resistance. So in this circuit we apply higher order differential equation. So I want to discuss how we can use higher order differential equation with constant coefficient in LCR circuit. So let I be the current. I be the current flowing in a circuit containing inductance L, capacitance C, and resistance R in series with voltage E electromotive force at any time. E is electromotive force, voltage E at any time in a circuit. Then that is known as a LCR circuit. There are three electrical components. So the diagram of this we have already made this, and this is inductance, okay, and this is capacitance, and this is resistance, and this is this one, and this E, okay. So this is current flow, this is current flow. So this is L, this is C, and this is R, and this is E. This is known as a LCR circuit. Now, we want to solve one problem, in which problem the application of second order differential equation with constant coefficient. So, problem 1 based on application of second order and first degree differential equation. Now, I am going to discuss problem 1 based on application of second order and first degree differential equation. So, problem is this: the damped LCR circuit is governed by the ordinary differential equation. This equation is given in our question, in our problem. The damped LCR circuit is governed by the ordinary differential equation where L, C, R are positive constant. Find the conditions under which the circuit number 1 is overdamped, number 2 underdamped, and number 3 critical damped. There are three conditions. This circuit is LCR circuit overdamped. First, second is underdamped, third is critical damped. So in this question we are discussing only these three problems, that our circuit is overdamped. What condition when circuit is overdamped? What condition when circuit is underdamped? What condition when circuit is critical damped? Also the critical resistance, and what is the value of resistance R when circuit is critical damped. So here I am making this diagram. I am telling you here, this is inductance and this is capacitance. This is resistance and this is E. This one. Okay. So this is L. This is this L and this C and this R and this E. So according to Kirchhoff's law have given in by voltage law, and any voltage drop from L, C, R, then voltage number 1 voltage drop from any inductance, then we write L di over dt. Number 2, and that voltage drop from the capacitance across the capacitance, then we write Q by C. And third point, that voltage drop across the resistance R, then that is Ri. Okay. So by voltage law, if any voltage drop across any electrical circuit from LCR, then we are algebraic sum of all LCR, algebraic sum. Algebraic sum means L, first is L. So L di over dt plus R, Ri, and plus C, Q by C equal to 0. This equation 1. 0, E 0. That is given in our question. E is 0 here. But we know that I is current. I equal to dq over dt. This equation 2. We have defined current I. I is the rate in change in charge. So I equal to dq over dt. We can put I equal to dq over dt in any place. So putting in 1, then we get. After putting I equal to dq over dt in equation 1, then we write this. L d over dt and I, this is the value of I, dq over dt, plus R, this is the value of I, dq over dt, plus qy is equal to 0. Now L, this is 2 time differential of q with respect to t, d2q over dt2 plus R dq over dt plus qy is equal to 0. This equation 4. So this equation is given in our question, in our problem. So E is 0 there, already given. Dividing by L in equation 4 on both sides we get. After dividing L, d2q over dt2 plus R by L, dq over dt plus q by L is equal to 0. This is equation 5. We see that in equation 5, EMF have given 0. Value of E is 0 here. Putting some assumptions in above equation 5, then we get. We are considering here some assumptions to solve equation 5. Considering assumptions, let R over L equal to 2P and 1 upon LC equal to W square. These two assumptions we are considering here. So this is equation 6. Let R by L equal to 2P and 1 upon LC equal to W square. After putting these values in equation 5, putting in 5, then we get. After putting these values in 5, now equation 5 becomes d2q over dt2 plus 2p. 2p is L by R. dq over dt plus W square. W square is 1 upon LC. L R by L, this is 2p. This is 2p. And W square, this is 1 upon LC. So now, here, Q is differentiating 2 times with respect to T. So we know that d over dt. This is differential operator with respect to T. d over dt. First time differential with respect to T. This is represented by capital D. Capital D is the differential operator with respect to T. And d2 over dt2, this is d square. This is second order differential with respect to T. So this is known as a second order differential operator. Second order differential operator with respect to T. After putting these values in equation 6, 5, then we get this. So d square plus 2pd plus W square, Q is the function. So Q taking is right hand side in the equation, not taking left side. This is taking right hand side. Q is the some function of T. Q is dependent variable and T is independent variable. So this equal to 0. This is equation 6. Now equation 6 right hand side is 0. So we here find only this is second order differential equation with constant coefficient. Second order means higher order. More than one order is known as a higher order. So this differential equation 6 is known as a higher order differential equation. Now finding solution of equation 6. So solution is Q is equal to CF plus PI. Complementary function plus particular integral, that is Q. What RHS is 0, so PI is 0. PI always be 0. Now auxiliary equation of 6. We find auxiliary equation of 6. We have discussed in several questions in last lecture in first order, higher order and first degree differential equation. How we can find CF, how we can find particular integral. So I am discussing their detail. So D equal to, putting D equal to M and removing Q from 6 is as given below. So M square, D is M, D square, so D is M, M square. 2PD, D is M, 2P, 2PM plus W square equal to 0. This is equation 7. This is known as a quadratic equation in M. And this equation have two roots. There is three cases. Roots may be equal, roots may be different, roots may be imaginary. Different roots are real roots. Equal roots are real roots. But roots may be imaginary. So now solution of equation 7 is given as below. Apply here Sridharacharya formula to solve any quadratic equation ax square plus bx plus c equal to 0. So in this quadratic equation, to find the roots of x, we apply Sridharacharya formula. So this is the value of x. M equal to minus b plus minus under root b square minus 4ac upon 2a. This is equation 8. After comparing this equation to given equation, this is general equation, and comparing this equation to given equation 6, then we find value of a, b, c. This equation 7. So now here from 7 we have value of a is 1, b is 2p, and q is w. Q is not c. C is w square. Small c is this. C is w square. Yes, c is w square. Putting value from 9 in equation 8, then we get. Equation 8 is Sridharacharya formula. Sridharacharya formula, putting the value of ABC. Then we find roots. So M equal to here minus 2p plus minus under root minus 2p ka square 4p square minus 4a, and c is w square upon 2a. A is 1. So 2 banja 2. And here 4 taking common from under root. Under root 4 taking common means we get 2. Out of under root we write 2. So 2 is common here. Minus p plus minus under root p square minus w square upon 2. So 2 is cancelled here. So M equal to, we find this. M equal to minus p plus minus under root p square minus w square. So there are two roots of M. M equal to 1 minus p plus minus and plus minus not plus under root p square minus w square. This is M1. Next is M equal to minus p minus under root p square minus w square. This equal to M2. What here? CF complementary function C1 or constant A e to the power M1x या M1t plus B e to the power M2t, because roots are different. So this is CF, this is complementary function, this equal to Q. There is no Pi. Q is equal to CF plus Pi. Q equal to CF and plus Pi. Complementary function plus particular integral. This is the complete solution. This is the value of Q. So Pi is 0. Because right hand side 0, so Pi is 0. Then Q is equal to only CF. So this formula is known as a CF. A e to the power, this is M1t, and plus B e to the power M2t. So this is the complete solution of given equation. Now case 1. Here taking case 1. P is greater than W. If P is greater than W, roots are real and distinct. When we apply this case 1, then we can decide roots are different, roots are equal, roots are imaginary. Without using case, we can't understand what is the condition of the roots. So case 1, we are taking in this solution case 1. First of all, we find this solution. In this solution, we taking the condition P is greater than W. P is greater than W means P square is greater than W square. So value of under root is positive. So there is distinct roots, real and distinct roots are there. Solution of equation 1 is this. After distinct roots, we have applied formula this. CF equal to A e to the power m1t plus B e to the power m2t. m1 and m2 are different roots. So here P is greater than W. We consider this condition P is greater than W. But P, what is value of P? R by 2L. In last slides we have taken the value of, we have taken 2P is R by L. So what is P is? R upon 2L. Next, W square is 1 upon LC. So W is under root 1 upon LC. So P is greater than W. P is R by 2L greater than W is under root 1 upon LC. So after solving this, we get R. R is this. This is R. Okay. So this is the case 1. If P is greater than W. Case 2, P is less than W. So in this case is, in case Q is always positive, this is the condition of overdamped. Q is always positive. So the value of this is overdamped, means our circuit is overdamped. Case 2, P is less than W, then we get, in this case, roots are imaginary. When P is less than W, then the value inside the roots is negative. Then value of root inside the negative means there is imaginary value. We have seen this root minus 1 is I. So there are imaginary roots. Oscillation decrease and this condition underdamping. If P is less than W, then electrical circuits is underdamping. If P is greater than W, then electrical circuit is overdamping. And case third, when P is W, then we have, in this case, roots are equal. P equal to W. P equal to W means P square equal to W square. So under root P square minus W square. So this result is 0. Then Q equal to minus P and minus P. Roots are same. Roots are equal. When roots are equal, in this case, electrical circuit critical damped and critical resistance is given by. So P equal to W, P is R by 2L, W is under root 1 upon LC. So R equal to 2 under root L upon C. This is the value of resistance. Now I want to solve one problem. In this problem, we apply higher order differential equation with constant coefficient. So that is very easy problem. Here a circuit consists of resistance of 5 ohm. Means in our circuit there is resistance is applied. So resistance R is 5 ohm. And inductance L. Inductance is also in our circuit. That is 0.05 Henry. At last, capacitance C. C is given 4 multiply 10 to the power minus 4 farad. So in our circuit, there are three components are using: resistance, inductance, and capacitance. So if here condition are given, if Q0 equal to 0 and I0 equal to 0, then find Qt. Q is some function of t, and you have to find value of Qt. Second is IT. I also some function of t. So these two results we have to find. In our problem, we have discussion what values is given in our problem. So in our problem given resistance. Resistance is 5 ohm. Next is inductance 0.05 Henry, and capacitance, this is 4 multiplied 10 to the power minus 4, and initially condition are also given. Q0 is 0 and I0 is 0. These two initially conditions are given. After apply these initial condition in our solution, then we find arbitrary constant, and again putting the value of arbitrary constant in our solution, then we find Q and I. So next we find out Q is the sum function of t. What is value of Q in terms of t, and also value of I in terms of t. So now start solution. Very important problem is this. Here the application of higher order differential equation with constant coefficient. So here making this diagram. This is diagram. This current flow. Okay. Here is L inductance. Here is C capacitance. Here is L inductance. Here is C capacitance. Here is R resistance. So by voltage law, we know why voltage law. Voltage law. Voltage law, total voltage drop across the circuit, then the algebraic sum is equal to total electric motive force equal to total EMF, electric motive force, E. Total electric motive force. So now first of all L is there in our circuit, L in our number 1 in our circuit, L is there, L. Then be total voltage, then voltage are voltage, this is L di over dt. Number 2 in circuit R, so voltage this equal to Ri. Next one, third, C in circuit is C, then voltage is Q by C. So these are the basic 3 points, and algebraic sum of these 3 results we write here L di over dt and plus Ri and plus QYC, this equal to E. This equation 1. This is the left hand side total volt. Total voltage across the circuit which are passing through inductance, resistance and capacitance. So sum of algebraic of voltage equal to total electric motive force. Now what we know I equal to dq over dt. Here is q is the some function of t. Now this value, this equation 2, this 2 putting in 1. This 2 from 2 putting in 1. We get. So here L d over dt of I and plus R of I and plus Q y c equal to E. So now putting L d over dt, I is dq over dt and plus R dq over dt and plus QYC, this equal to E. Now L d2 q over dt2 plus R dq over dt and plus q by c equal to E. This equation number 3. Okay. Dividing by L in 3 on both sides. On both sides. Then we get d2 q over dt2 plus ryl dq over dt and plus 1 upon LC q equal to E by L. This equation 4. Now here putting, let RYL is 2P and 1 upon LC is W square. This equation 5. Putting this result here in this question, d2q over dt2 and plus 2p dq over dt and plus 1 upon LC is W square. Q equal to E by L. This equation is 5. 6. Now putting this result, d over dt is capital D and d2 over dt2 is capital D square. So putting this result, then we get here d square plus 2p d and plus W square and into Q is equal to E by L. What is E? E is electric motive force. How many E there in our problem? E is 110 volts. Here E is given 110 volt. This is given in our question. 110 volts. Okay. And L is inductance, that is given 0.05 Henry. This value given in question. This is given in question. Okay. So now putting here d square plus 2p d and plus w square into q is equal to E110 upon 0.05. So point, we are putting 0. Multiply by 5. So 5 2s are 10 and 5 2s are 10. This is 220. 1100 volt तो नहीं है, 110 volts. Okay. This result. So now d square n plus 2p d plus w square into q is equal to 220. So now this is equation number 7. Equation 7 is, this is differential equation of second order, okay, with constant coefficient. Now here value of q is CF n plus pi, particular integral. First we find out CF and then we find pi. So finding CF of 7, finding CF of equation 7. So here putting d equal to small m and removing q. And taking RHS equal to 0. So question is this, here m square plus 2pm and plus w square and this equal to 0. This is equation 8. Okay. Now this is known as a auxiliary form. This is known as a auxiliary form. As an auxiliary form. Now value of this m equal to minus 2p plus minus under root p square 4p square minus 4 into 1 into w square upon 2a, 2 into 1. So m equal to here minus 2p, 2 is common here, minus p plus minus, this 2 is common, so here under root p square minus w square and upon 2. So 2 is cancelled. So m equal to here, first root is minus p plus under root p square minus w square and next is m equal to minus p minus under root p square minus w square. Okay. So these are two roots. So roots are different. So now CF is a e to the power m1t and plus b e to the power m2t. This is CF, complementary function. This is formula for complementary function for different roots. Okay. Putting value here, CF is equal to a e to the power minus p plus under root p square minus w square n into t plus b e to the power minus p minus under root p square minus w square n into t. So this is the complementary function of given equation. Now finding pi, particular integral. Now pi, particular integral, pi equal to 1 upon fd into q, fd into q, q means here right hand side, so here is q, fd into here e upon l. What is fd? fd is given here d square and plus 2pd and plus w square and e upon l here. What is e upon l? 220. Here is 110 volts, 110.5, 220 volts. Here may be mistake, 210. Chalo, usi se bas. So here is E. E upon L. What is E upon L is? What is E upon L? E, value of E upon L, 220. This. So putting 220 here, 220. Okay, this is constant. So constant term taking this side, here 200, and now taking 1 upon w square is common and w square common, so we are taking 1 plus d square plus 2pd upon w square whole to the power minus 1. So this is 1 only. Here I am finding particular integral pi. Okay, so what is value of w? I am finding out value of w here putting. So here is only 1 taking. Now pi is equal to 1 upon, what is common here? W square. This is not, this is 220. So 220 upon w square and in 1 only. Now d square taking common, highest power of d. Lowest power of d taking common. So 1. W square taking common. So 1 plus this upon w square. So d is differentiate, correct, here w square. So this is pi. Now here we find out value of w. So here 1 upon LC is w square. Okay, 1 upon LC. So what is C? Capacitance. In our question, value of capacitance is capacitance 4 multiply 10 to the power minus 4, and LC, L is 0.05. Capacitance 4 multiply 10 to the power minus 4 into capacitance 0.05. This is W square. Okay. So this goes to numerator and 4 5 are 20. So now this point is cancelled. Here is 100. So W square is, here is 100 and into 10 to the power kitna? 4 minus plus 4 upon 4 5 are 20. So only 1 0 is cancelled and 2 5 are 10. So here 50,000. This is the value of W square, 50,000. So now putting here 220 upon 50,000. So this 2 is cancelled and this equal to 211 ja, and upon here is 5,000. 5,000 means 2,500. This is value of pi. Particular integral we have find 11 of 2,500. Okay. Now complete solution Q is equal to CF and plus PI. So what is CF? CF we have find A e to the power different roots e to the power here minus p and plus under root p square minus w square n into t plus b plus v e to the power minus p minus under root p square minus w square n into t and plus 11 upon 2500. This is CF plus PI. This is CF and this PI. Okay. This is the value of Q. Q is the sum function of T here. So this is the value of Q. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.